Good morning. In the last video, we discussed about implicit function. How to find the derivative of implicit function. A function which can be expressed in the form y is equal to f of x is called an explicit function. A function which can be expressed in the form f of xy is equal to 0 is called implicit function. That means a function y cannot be directly expressed in terms of y. X is called implicit function. Now we know how to find the derivative of implicit function. Now I discuss two more problems based on implicit function. How to find the derivative of implicit function? X cube plus x square into y plus x into y square plus y cube is equal to 0. Now differentiating with respect to x, we get answer 3x square plus, here we apply product, that is first into derivative of y with respect to x is dy by dx plus second into the derivative x square is 2x plus, here again we apply product rule, x into derivative y square is 2y into using function of function y derivative is dy by dx plus y square into derivative x with respect to x is 1 plus y cube derivative is 3y square into dy by dx is equal to 0. Now we collect the derivative dy by this term, that is dy by dx into x square plus 2xy plus 3y square is equal to minus 3x square minus 2xy minus y square, and therefore final answer we get answer minus of 3x square plus 2xy plus y square the whole divided by x square plus 2xy plus 3y square. That's all. Similarly, the sine cube x plus cos cube y is equal to suppose a constant k. How to find the derivative functions? Clearly, as an implicit function. First, differentiating with respect to x, we get answer 3 sine square x into derivative sine x is cos x plus 3 cos square y into derivative cos y is minus sine y into derivative y with respect to x is dy by dx and derivative k with respect to x is 0. This is minus 3 cos square y into sine y into dy by dx is equal to minus 3 sine square x into cos x, and therefore dy by dx is equal to minus 3 sine square x into cos x divided by minus 3 cos square y into sine y equal to final answer sine square x into cos x divided by cos square y into sine y. Now we have to discuss some special type questions, special problems, that means higher order thinking type questions, HOT type questions based on implicit function. Now the first special case is the one. It's a very important question. There are some different types of questions. So try to understand and practice. If sine y is equal to x into sine of a plus y. It's a very important question. Sine y is equal to this type of question is very important. Sine y is equal to x into sine of a plus y. Then prove that dy by dx is equal to sine square a plus y divided by sine a. Here, you know what is to be proved. Here we have to prove that dy by dx is equal to sin square of a plus y divided by sin a. On the right side term, the term contains only one variable, that variable is y. That means, first we express the given function in terms of y alone. Because here the function we have to prove that sin square of a plus y by sin a is equal to sin square of a plus y by sin a. That means our function contains only one variable, that is y. So first we set this function in terms of y alone, that is x is equal to f of y form. So first we cross multiply this term, we get answer sin y divided by sin of a plus y is equal to x. That is x is equal to, we get sin y divided by sin of a plus y. That means our function contains the only one variable, that is y. That is x is equal to f of y form. It is an explicit function of y. Now differentiating this function with respect to y. That means d by dy of x is equal to, using quotient rule, because our function contains the variable is y, so we are differentiating with respect to y. Denominator, that is sin of a plus y into derivative of sin y, that is cos y into function derivative of y with respect to y is 1 minus sin y into derivative of sin a plus y cos of a plus y. Then using function we get answer 1 because derivative is 0 and derivative y with respect to y is 1 divided by denominator square, that is sin square of a plus. And therefore numerator is of the form sin a cos b minus cos a sin b. You know the result? Sin a cos b minus cos a sin b is equal to sin of a minus b. That is equal to sin of a minus b. Here a and a corresponding value is a plus y and b corresponding value is y. The whole divided by denominator square sin square of a plus y. Here y cancel and therefore we get answer sin a divided by sin square of a plus y. This is dx by dt. Now we find dy by dx. For finding dy by dx, we take the reciprocal of this term, that is we get answer sin square of a plus y divided by sin a. That's all. Equal is equal to, we get answer sin square of a plus y divided by sin. Now write one more question based on this type. Special case. Cos x is equal to y into cos of a plus x. Prove that dy by dx is equal to sin a divided by cos square a plus x. Check. What is to be proved? dy by dx is equal to prove that sin a by cos square of a plus x. That means on the right side we have to prove that sin a divided by cos square x, cos square of a plus, which contains only one variable, that is x. That means our function can be expressed in the form y is equal to f of x. Now last question, on the right side we contain the only one variable is y. So that function converted into y is equal to, x is equal to f of y form. Here the function is converted to the form y is equal to f of x, because on the proved term it contains only one variable is x. So first we cross multiply this term, we get answer y is equal to cos x divided by cos of a plus x. Now differentiate. Our function is the explicit function x, so differentiating with respect to x. That means d by dx of y. Using quotient rule, denominator, that is cos of a plus x into derivative of cos minus sin x minus numerator, that is cos x into derivative of cos a plus x minus or minus plus sin of a plus x, the whole divided by denominator square, that is cos square of a plus x. That is equal to, your numerator is on the form sin a cos b minus cos a sin b. That means sin of a plus x into cos x minus cos of a plus x into sin x. The whole divided by cos square of a plus x. And therefore numerator is of the form sin a cos b minus cos sin b. You know the result, sin a cos b minus cos sin b is equal to sin of a minus b. Using that result, we can sin of a corresponding angle is a plus x and b corresponding to x. The whole divided by cos square of a plus x. Here x is cancelled and therefore we get answer sin a divided by cos square of a plus x. dy by dx is equal to, we get answer sin a divided by cos square of a plus x. Now write two more questions for home assignment. Sin x equal to y into sin of b plus x. So that dy by dx equal to sin b divided by sin square of b plus x. Second question, cos y equal to x into cos of a plus y. Here we have to prove that dy by dx equal to cos square of a plus y divided by sin a. Okay. Try to answer these two questions based on special case 1. Now we discuss special case 2. SC2 is also very important question. So for our question, if x into root of 1 plus y in the root of 1 plus x equal to 0, prove that dy by dx is equal to minus 1 divided by 1 plus x the whole square. Here the proof, what is the proof? Dy by dx equal to, prove that minus 1 by 1 plus x the whole square. That means on the right side term and then only the one variable is x. So first we said that given implicit function in the form of y is equal to f of x, because our function is a proved function is dy by dx equal to f of x, I mean minus 1 by 1 plus x the whole square. That only the one variable is x. So first we said that a given function in the form of y is equal to f of x. First we are removing the root terms. So first we shift the second term to the right side. That is x into square root of 1 plus y is equal to, we get answer minus y into root of 1 plus x. Now squaring on both sides. Therefore we get answer x square into 1 plus y is equal to minus square is 4 plus y square into 1 plus x. Now multiply this term, we get answer x square into 1 plus x square into y is equal to y square into 1 plus y square into x. Now we shift the right side term to the left side and we group same power term, that is x square minus y square. So in the first bracket plus second term x square y minus y square x is equal to 0. Now factorize, this is the form a square minus b square. You know a square minus b square is a plus b into a minus b, and therefore x square minus y square is x plus y into x minus y. Plus here x into y is a common term. Balance x minus y is equal to 0. These two terms containing x minus y as a common fact. Now you collect x minus y. Balance x plus y plus x into y is equal to 0. Now using zero factorization theorem. Either first factor equals 0 or second factor equals 0. That means if a into b equals 0, either a equals 0 or b equals 0. Using that theorem, we get answer either x minus y equals 0 or x plus y plus x into y equal to 0. Using this result, we get answer x equal to y. This condition not satisfied the given question. So we avoid this term. Now the second factor, we get x plus y plus x into y equal to 0. The x plus y plus x into y equal to 0. Here y plus, therefore y plus xy equal to, we get answer minus x. We said the given function the form y is equal to f of x. So we collect y term, that is we take y as a common term, that is y into 1 plus x equal to, we get answer minus x, and therefore y is equal to minus x divided by 1 plus x. Therefore given function is of the form y is equal to f of x. Now differentiate with respect to x. That means dy by dx is equal to minus of, here minus is a common term, so we take minus of, then we apply quotient rule. Minus of x by 1 plus x means minus of x by 1 plus x. Using quotient rule, we get answer denominator square, that is 1 plus x the whole square. Denominator, that is 1 plus x into, the derivative, that is minus of means minus of x by 1 plus x. So denominator into derivative x, the derivative x is 1 into 1 minus numerator is x into derivative denominator, derivative 1 becomes 0 and derivative x is 1 into 1. That is equal to minus of 1 plus x minus x the whole divided by 1 plus x the whole square. Here x is cancelled and therefore we get answer minus 1 divided by 1 plus x the whole square. That's all. And therefore dy by dx equal to, we get answer minus 1 by 1 plus x the whole square. This is a very important question. First you use the second time to right side for moving root term, squaring on both sides. Then multiply and collect the terms on the left side and group it with the same power term, that is x square minus y square and x square y minus y square x equal to 0. The factors using the identity, you get the answer x plus y into x minus y. Here x y as a common term, then we collect x minus y as a common factor. Using 0 factorization theorem, and the first factor equals 0, you get x equal to y, which does not satisfy the given equation. Now using the second factor, we get y is equal to minus of x by 1 plus x. Now using quotient rule, we get answer dy by dx is equal to minus 1. Using quotient rule, we get answer minus 1 divided by 1 plus x the whole square. Now we discuss the third and fourth special problems on the next video. Thank you.